Okay, there are some power reducing formulas out there. There's one in your book, and you can look them up if you want. There's one for sine, cosine, and tangent. But I'm here to tell you, they only work for a certain little niche type of problem. All right? So it's much easier if you realize sine and cosine, odd exponent, pull it out, make it a du. Even exponents, power reducing and work them through, right? That's what you have to do because it doesn't work if two things are multiplied together. They only work if they're independent like this one. The reason why I am putting secant on here, because I think you have a homework problem that needs this. You get to a certain value and you have that secant that's to a higher exponent, and so you have to have that and be able to pull that out and make it its own integral and then work it that way. All right? I am not going to put a problem like that on a quiz or a test. But it's one of those things where in my math lab, some of you are going to get a problem that needs this. Some of you are not. But you know how they put crazy crap in there on my math lab, so just be aware. That's why I'm putting it in the notes so you can come back to it if you need it. The problems that I will give you are the problems like the ones we're getting ready to do. So I feel like we've exhausted sine and cosine. We've looked through those thoroughly. What if I have something like this? Example 3. I'm going to integrate tangent to the fourth x dx. It's always about the toolbox, right? We know our identities. Those come out with this. So look at what's in your toolbox and then think about it. We know a couple things about tangent. Tangent squared x plus 1 is secant squared. We know that the derivative of tangent is also secant squared, right? So it looks to me, whenever I'm talking in terms of tangent, I need an even exponent because I'm coming out here with secant squared. Ah, right? Okay, let's do this thing. So if I break up tangent here to get a tangent squared that I'm looking at. So if I have a tangent squared x, and I break this off to have, another tangent squared x dx. How do we want to do that? Tangent squared, I can work with that in terms of secant, so let's try that. Tangent squared x, what if I turn one of these into secant? Where it is secant squared x minus 1 dx. Ah, there it is. There it is. Okay. So here, because, right, you just subtract 1 over here from that side to get there. Now look at what happens whenever I do this substitution. Oh, dang it. I didn't mean substitution yet. My head's going faster than my mouth. If I distribute that, scoot this up, we now have tangent squared x, secant squared x minus a tangent squared x dx. Now, identity, identity, identity. That's what we're looking for here. I'm going to break this off because if I have tangent squared x, secant squared x dx minus, and I take this tangent squared and I have secant squared x minus 1, look at what just happened. If I make a u tangent x on this side, my du is the secant squared. There's my du because of derivatives of what we know. Now I have a polynomial again. I am integrating u squared du, so I've got a 1/3 u cubed plus c, and I know that's tangent. 1/3 tangent cubed x plus c. Let's come over here. I have a negative, and I'm integrating secant squared x minus 1 We automatically know that. That is tangent, ladies and gentlemen, because the antiderivative of secant squared is tangent. Minus x. That's cool, right? Yeah, it is. So I'm going to distribute this, and I'm going to write this as negative, oh my, negative tangent x plus x. And then we put these together. Let's go back to blue. My final answer is a 1/3 tangent cubed x minus tangent x plus c. The big deal with these, the great big deal that goes with these, is that you have to figure out a way to manipulate what you already know. What do I know? What's a derivative of tangent? What are my identities? How can I work this around, right? Different things in your toolbox, just like you had to do in trig. How can I manipulate this in order to pull it off into something that I want it to be? Okay.